has crossed the border in strength. The response, outflank it. To make the airborne mission possible, A-10s provide close support with heavy aerial artillery. Thousands of miles to the east, A-10s are given another assignment. Thread your way through rugged mountain passes and valleys in adverse weather and interdict an invader's supply line. The third mission is ordered, in darkness, on the other side of the world. A boat is approaching shore to land a band of guerrillas. The mission, find the boat and destroy it. These differing missions, close support, interdiction, and counterinsurgency, are carried out with differing ordnance by the same versatile airplane. The Fairchild Republic A-10 Thunderbolt II, the multi-mission defender. Third world nations may face multiple challenges to their security. Border incursions by hostile neighbors, superpower aggression, directly or by surrogate, and domestic subversion. Yet, while challenges may be multiple, resources available for defense often are limited. In these circumstances, a weapon versatile enough to perform multiple tasks is highly desirable. The requirements are diverse. Paratroops dropped in desert terrain need a support weapon that can operate from austere fields, seek out enemy positions with pinpoint accuracy, provide forward air control, suppress opposing fire, interdict supplies, remain around the battlefield for an extended time, and deliver devastating firepower. Interdiction in bad weather demands additional qualities: long-range, precise navigation, a heavy payload, and the ability to maneuver through rugged terrain at low altitudes and find the target. The third mission extends the list of specifications. Guerrilla forces habitually move under cover of darkness. Finding them means being able to follow variable terrain at night and detect their presence and location. It may mean finding vehicles on land and ships moving offshore, and being able to select among a range of ordnance for the weapons best suited to each task. In summary, an effective multiple mission defense requires heavy, accurate firepower, a variety of ordnance, long range and endurance enough to loiter around an area for an extended time or travel long distances without refueling. Survivability, the ability to operate under rugged conditions, absorb punishment, and continue to fly. Short takeoff and landing ability, allowing operation from austere fields or roads. Sustained performance, the ability to fly multiple sorties from forward areas with only minor maintenance. Ease of repair. Hard-to-fix airplanes are of little use in remote locations. The ability to fly at night and in bad weather to find the enemy under these conditions and to stop him. Adaptability to changing roles. The multi-mission airplane may be called upon to provide close support, suppress enemy fire, serve as forward air control, escort or attack helicopters, escort or attack ship convoys, and attack the enemy with varying weapons from varying altitudes. The list of needs is formidable. So is the response. The A-10 Thunderbolt II. First, fire firepower. The airplane is a flying cannon. The pilot sits atop a 2-ton, 6-meter-long, 30-millimeter rotary cannon. The gun is made by the General Electric Corporation. It has 7 barrels, fires up to 70 rounds a second, and is accurate at 2,000 meters, farther than the best Soviet anti-aircraft weapons can reach. The potent 30-millimeter ammunition is made by Honeywell and Aerojet General. The power of the GE gun has been demonstrated dramatically in Air Force tests. A 1-second burst will punch through the Soviet Union's T-72 tank armor, destroy lighter vehicles, and stop trains and ships. The A-10 carries an external load of 7.3 metric tons of mixed ordnance on 11 underwing pylon stations. One typical load is 6 TV-guided Maverick air-to-surface missiles made by Hughes Aircraft. Another is 4 1-ton laser-guided bombs, or 28 500-pound anti-personnel bombs. Accuracy is enhanced by Martin Marietta's Penny Laser Spot Seeker. The Thunderbolt can fly 460 kilometers, stay over a target area for 2 hours, and come home with 20 minutes of fuel left. Or it can strike a target 1,000 kilometers away. The key to the A-10's range and endurance is its 2 fuel-efficient GE turbofan engines. Each is rated at 4,100 kilograms of thrust. Internal fuel capacity is 6,200 liters. 3 external tanks, when needed, add another 6,800 liters. The system also is equipped for in-flight refueling to provide unlimited range. The exceptional survivability of the A-10 begins with its rugged construction. The Thunderbolt can lose an engine, part of a wing, and half a tail, and still fly. The pilot sits in a bathtub of titanium armor. In test firings, 23-millimeter armor-piercing incendiary and high-explosive rounds have discolored the armor, and 37-millimeter rounds have dented it. Fuel tanks are fire-resistant, self-sealing, and protected by foam. The flight control system is triple redundant. If both hydraulic systems are lost, the pilot still can fly manually. Pilot fatigue is reduced by a balanced heating and cooling system designed by Hamilton Standard. Survivability is enhanced by the airplane's performance and tactics. The A-10 is designed to fly and maneuver close to the ground. A deceptive painting scheme makes it hard to see from above, and missile radars have trouble distinguishing it from background clutter. The A-10 can turn within a radius of 300 meters. It can quickly rotate its tail away from heat-seeking missiles. And any jet fighter that tries to mush in low and make a 6 o'clock attack runs a terrible risk. As tests have shown, the A-10 can turn into the attacker with his lethal gun. The hunter becomes the hunted. On an open battlefield, the pilot can fly below anti-aircraft radar. Pull up just high enough to sight his target. Fire at it without flying over it, and break the lock of enemy radar and heat seekers by turning away, hitting the deck, or using masking terrain. The A-10's package of electronic countermeasures also helps to confuse enemy gunners. Tracor heat flares pop out automatically to confuse infrared missiles. Tracor chaff dispensers degrade radar. The Westinghouse ECM system jams enemy frequencies and denies the enemy accurate fire control. The A-10's ability to take off and land on short, rugged fields has been proven in repeated tests. The auxiliary power unit made by Garrett allows easy self-starting without external help. The airplane can fly from any relatively flat surface 1,000 meters long. The heavy-duty landing gear made by Bendix and Manasco and the Goodyear tires, wheels, and brakes allow routine operation from unimproved fields and roads. In one test, each of 2 Thunderbolts flew 17 sorties between sunrise and sunset. Servicing is fast, with easy, single-point refueling. The A-10's heavy-duty construction demands minimum maintenance. Since the airplane is designed with few exotic materials and compound curves, repairs can be made quickly and easily. Numerous inspection openings and easy access to internal parts simplify the work. Mechanics can be trained quickly with relatively simple tools. An engine can be removed and replaced within 40 minutes. To fly when others are grounded, the A-10 pilot calls upon an advanced system. The picture you are seeing is about half as bright as you would see it in the cockpit. The pilot sees by looking at an advanced heads-up display developed by Kaiser Industries. With the HUD, he flies heads-up just as he is trained to do in daylight. An inertial navigation system made by Litton Industries tells him where he is at all times. The pilot flies and finds his target by using a combination of complementary systems, a forward-looking receiver called FLIR, and a multi-mode millimeter wave radar system made by Westinghouse. The radar modes provide a map of the ground, detect hostile radars, and locate moving ground targets. The pilot views the systems on the HUD and on special displays located just beneath it for maximum heads-up operation. The pilot is seeking vehicles along a road that guerrilla forces are using at night. The FLIR image displayed on his HUD detects heat patterns from terrain, vehicle engines, and human bodies. A terrain following and terrain avoidance display generated by the Westinghouse radar is superimposed on the FLIR video. Contour lines showing the terrain 1 and 2 miles ahead of the aircraft allow the pilot to anticipate the terrain and mask himself to avoid detection. He clears the terrain at a selected altitude by following commands from the terrain-following steering box. The radar altimeter provides a low-altitude emergency warning. The target is found by the radar's ground-moving target indicator, which detects targets moving as slowly as 3 knots. The pilot switches to the FLIR, identifies the target as a hostile vehicle, and attacks. The enemy finds himself as unsafe in the dark as he was during the day. The third world nation may face multiple challenges to its security: incursion by a hostile neighbor, superpower aggression, directly or by surrogate, or insurgency. The responses must be multiple too. Defense against a frontal attack, interdiction of vehicles and supplies, and search and destruction of guerrilla forces. The needs of the defense are formidable. And so is the response. The A-10 Thunderbolt II, the multi-mission defender. What you have just seen hasn't happened yet, but it could anytime, anywhere along the border between NATO and the Warsaw Pact forces. If and when it happens, we can be certain of two things only. One, NATO forces will be outnumbered in every category. And two, our ground forces will be given close air support, the closest ever given, from the fighter designed by Fairchild specifically to kill tanks, the A-10 Thunderbolt II. Bentwaters, an air base near the east coast of England, is the home of the 81st Tactical Fighter Wing. Operational strength, 6 squadrons, 108 A-10s. Mission, to provide close air support to NATO forces, where and when it's needed. The operational concept of the 81st is simple and clear. Forward deployment, rearward maintenance. Bentwaters serves as the command and maintenance center for the wing. Hundreds of miles to the east in central Germany are 4 FOLs, forward operating locations. The A-10s and support personnel are rotated to the FOLs to work and train in the area where they would be fighting in time of war. These FOLs are equipped for quick turnaround operations, including fueling, arming, and quick fix repairs. The A-10 is ideally suited to this forward basing. It has already established a reputation for the best combat readiness rate of any fighter aircraft. This readiness rate spells constant availability, availability to fly and fight, perhaps the most important attribute a combat fighter can have when facing the numerical advantage enjoyed by the Warsaw Pact. Armed with 6 Maverick missiles and nearly 1,200 rounds of 30mm cannon ammunition, the A-10 can range 150 miles, stay over a target area for 2 hours, and return with an ample fuel reserve. If need be, the A-10 could be landed and operated from dispersal points close to the front. Locations with as little as 2,000-foot runways, civilian or Army strips, even stretches of Autobahn can be used. One important benefit of the forward operating location concept is that it permits A-10 pilots to become thoroughly familiar with the terrain adjacent to the border, terrain that an attacking force would have to traverse. The speed of the A-10 allows the pilot to fly in and around the contours instead of merely across ridge lines. Other fighters are incapable of making steep turns in narrow valleys and sighting targets early enough to identify and engage them. Unlike other fighters, the A-10 pays no penalty in turn performance at this lower speed regime. The short turning radius permits the A-10 to rapidly attack a target, or just as quickly to prevent an enemy from taking an easy shot at it. The A-10 can rapidly maneuver to confuse heat-seeking missiles, and under pursuit, turn the hunter into the hunted. The density of the Warsaw Pact missile systems, anti-aircraft guns, and airborne interceptors makes it clear that NATO aircraft can expect to take punishment. But the A-10 is survivable. It was designed that way. The A-10's firepower is lethal. It can carry up to 16,000 pounds of ordnance on its 11 underwing stations. Air Force planners describe a typical anti-armor combat load for the A-10 as being 6 Maverick missiles and a full complement of 30mm ammo. The Maverick missile has an exceptionally high probability of killing a tank, while the A-10's cannon has demonstrated outstanding kill power against Soviet tanks under actual test conditions. These weapons pay the pilot another bonus by virtue of their standoff capability. The A-10 pilot can fire either the missile or the cannon and turn away to stay out of the lethal envelope of enemy guns and missiles. Other fighters, which must rely on free-fall bombs, expose themselves to enemy fire when they fly over the targets to a release point. Weather severely limits the ordnance loading for other fighters. As the visibility decreases, further limitations are imposed on faster and less maneuverable aircraft. The diminished visual range prevents them from engaging a target unless it is almost directly on the nose. Most of the time, this means maneuvering for a second pass, and this most likely means never seeing the same target again. Without question, the A-10 has demonstrated its ability to work under the weather anywhere. The airplane for the mission, with all the qualities to perform it: ruggedness, survivability, massive lethal firepower. The A-10, now operational in NATO. Planners, recognizing the need to provide for capability growth in the A-10, ensured that the original design allowed for simple expansion to a two-seat configuration. Now this straightforward growth, complete with the necessary avionic tools, has demonstrated its ability to effectively deal with the other half of the vulnerable time. The answer to the night close air support question, the night adverse weather A-10. The Night Adverse Weather A-10, or NAW as it is called, is a modified single-seat A-10. The result is tandem cockpits, each with a full set of flight controls, an increased canopy area with two side-opening canopies, extended vertical tails, and an array of avionics to perform the mission. The NAW retains the fuel and ordnance capability of the basic A-10. The avionics which have been added are a forward-looking infrared receiver and a radar, each mounted in pods under the wing, an inertial navigation system, a radar altimeter to accurately measure altitude above the terrain, a laser ranger, and a low light level TV system. And finally, a modified head-up display to present all this information to the pilot. This system is missionized to take advantage of the two-man crew. The pilot flies the aircraft and engages the targets handed off by the electronic systems operator. The ESO, in turn, navigates the aircraft, searches for targets with complementary systems, and then cues the pilot through weapons delivery.
Okay, the mission for tonight is to attack a suspected concentration of tanks here. Our route of flight will be to start here and to use not only the cover of darkness, but also a low-altitude technique for maximum terrain masking throughout this complete route. We will hug the ridgeline on this side and the west side here, so that throughout the whole flight, we will never be higher than any kind of surrounding terrain. So we'll use the valleys all the way through here, making a sweeping turn, and depending upon where the target is, we will reattack coming in this way to this point.
To meet the threat of the heavily defended armored forces, the Night Adverse Weather A-10 will employ the 30mm GAU-8A cannon, and when available, the imaging infrared Maverick missile to capitalize on standoff. While achieving standoff, these weapons permit firing at very low altitudes, further enhancing survivability through terrain masking. The NAW A-10, with the same excellent low-altitude maneuverability of the single-seat A-10, is able to apply this characteristic at night, aided by its avionics. This spells survivability. Staying down amongst the terrain while delivering lethal ordnance from a distance, never having to pop up into the missile threat area. En route to the target during an actual night mission, the ESO uses all of the complementary systems to accurately navigate and pick his way through the terrain.
Well, we open up in front of us there?
Yeah.
Went by that one at a couple hundred feet.
Yep, sure did.
The forward-looking infrared receiver, FLIR, presents a picture of daylight clarity to both cockpits by distinguishing heat patterns on the surface.
Okay,
The ESO controls the FLIR in both azimuth and elevation, as well as magnification for longer range work.
Looks like all its low spot ahead anyway. Yeah, that is at 70 miles. We'll hold this and we'll make the turn back.
Finding an area of interest, such as a navigation turn point or a possible target, the ESO is able to generate a cueing box to overlay the subject and to project this on the pilot's head-up display.
Right down through there. That's interesting. What's up? Going down this valley at night. Yeah, sure is.
As the pilot rolls into a turn using FLIR information, the ESO brings up the low light level TV, momentarily replacing the FLIR imagery. The LLTV gains its real-world display from illumination by minute light sources, such as stars or other small lights on or near the Earth's surface. This excellent picture can be provided to the pilot while the ESO slews the FLIR to one side or the other, cross-checking terrain or searching for targets. The pilot's display in the HUD is a real-world display, just as in daylight, with several redundant systems contributing cross-checks and a variety of performance under different weather conditions. The ESO switches to a radar display, utilizing a moving target indicator mode.
I see something up ahead there. Yeah, some way up. I see something out there, probably about 4 miles.
This sensor, which can look through the weather when the FLIR may be degraded, can isolate on only those returns that are moving at 4 knots or more and show them as bright targets on both cockpit displays.
10 degrees. There's a big truck right ahead. It's about 2 miles. There's the target right down in there. You give me 41. You get 41 to fire a laser. Okay, that's the truck right under your pepper right now. There. Okay. That's it. Now a little bit to the right, left. Okay. Ah, that was a good hit, Wendy.
The simplicity and straightforwardness of this system makes aircrew transition quick and builds solid confidence on its employment. The combination of firepower delivered at very low altitude and the flexibility of a two-man team to react to the demands of the night and adverse weather environment come together to demonstrate a survivable system. One that is capable of extending TAC air responsiveness around the clock. One that is affordable. One that is available now. The Night Adverse Weather A-10.